against my better judgment, I'm putting together a video for all the AP free response problems from beginning to end. I put up all the AP free response problems on the web page, starting from 2018, going all the way back, and we're going to do them together. I'm going to try to go a little bit quicker than normal. Given velocity, I'm making sure I notice this. I'm writing that down. X of 0 equals 5, negative 5. I'm asked to find the acceleration. I'm going to go ahead and use Math 8 in my calculator. That's n-derive. Because I don't want to use derivative rules to take the derivative of this. It's got quotients, it's got a chain. So instead, in my calculator, I'm going to go Math 8, n-derive 10 sine 0.4 t squared divided by, I don't have to worry about the top in parentheses. The bottom needs to be in parentheses. T squared minus t plus 3, close out parentheses, with respect to x at x equals 3. Obviously, I know that the derivative of velocity is acceleration, and acceleration at 3 is negative 2.118. Remember, 3 decimal places you can truncate. Find the position. So I can't anti-derive to find a position function. So instead, I'm going to have to do an unknown position, an ending position equals a known starting position, plus my displacement, which my calculator will calculate. Displacement is the area under the velocity curve. So I'm going to go ahead and do negative 5 plus Math 9, the integral of 10 sine 0.4 x squared divided by x squared minus x plus 3, close parentheses, with respect to x at from 0 to 3. Okay, I get negative 1.760. That's B, part C. Evaluate the integral from 0 to 3.5. And the absolute value. So I'm going to pull this back up, or second entry. Delete this. I'm going from 0 to 3.5. Close my parentheses. 2.843. And then I'll do the same thing for the absolute value. So pull this back up, or second entry. I'm going to insert an absolute value. I'm going to close the parentheses, so I close the argument. If you ever get an argument error, it's because you don't have the right amount of parentheses. So check your parentheses. If you have the newer operating system, this is easier, 3.737. Interpret the meaning of each in the context of the problem. This is displacement from 0 to 3.5 seconds. This is the distance traveled from 0 to 3.5 seconds. Part D, second particle moves along the axis. At what time are the two particles moving at the same velocity? Okay, well, x2, t squared minus t, its derivative would be the velocity of the second particle. That's 2t minus 1. I will set that equal to the velocity of particle 1. So in my calculator, 2t minus 1, and then 10 sine 0.4 t squared, close parentheses, divided by, you don't need the numerator in parentheses because it's multiplication. If it was addition, you need the numerator in parentheses, t squared minus t plus 3. Graph, find the intersection. Those are when the velocities are going to be equal to each other. X would be t. At time 1.547, we'll have the same velocities as 2.141. Okay, 2017. This is a no calculator question. You'll have 2 no calculator questions. You'll have 3 calculator questions. Okay, I'm given the position of particle P, I'm given the velocity of particle Q, and I'm given an initial position of particle Q. I'm told that x of 0 is 5. I'm going to write that down, and this is just for particle Q. Okay, no calculator. Part A, when is particle P moving to the left? Okay, so moving left when your velocity is 0, when your velocity is negative. So I'll take the derivative of x of p to get v of p. Using the chain rule, the derivative of log is 1 over. That's the derivative of the outside times the derivative of the inside, which is 2t minus 2. I'm going to have to set this equal to 0. 2t minus 2 over t squared minus 2t plus 10. The denominator doesn't factor. We're really going to have to worry about the numerator. The numerator equals 0 at 1. I then can do a sign analysis. I'm going from 0 to 1, 8. Make sure you pay attention to your domain of 1. Plug in something like 0.5, and that will be a negative. This will be a positive for sure. So negative. Plug in something like 3, positive, positive. Positive. So this is velocity. So velocity is negative here, traveling left from 0 to 1 because v is negative. Part B. One of the 2 particles traveling in the same direction. So one of the velocities equaling the same sign. I analyze the velocity of particle P. Let's analyze the velocity of particle Q. So this is the velocity of P. Let's look at v of Q. I'm going to set that equal to 0. To analyze the velocity, I got to do a sign analysis. I got t squared minus 8t plus 15. I'll set that equal to 0. I get t minus 5t minus 3. Set that equal to 0. I get t equals 5 and 3. Okay, so I'll do a sign analysis here. We're going from 0 to 8 again. This is the velocity of Q. I got 3 and 5. Got positives to the right of 5, negatives between 3 and 5, positives between 0 and 3. That's a negative times a negative. So one of my velocities in the same direction. So 0 to 1 is negative. So there's never going to be traveling in the same direction to the left. We're going to be traveling in the same direction from 1 to 3, and then 5 to 8. C. Find the acceleration of particle Q at t equals 2. There's Q, the acceleration. The prime of Q would equal A of Q, which is 2t minus 8. A of Q at 2 is 4 minus 8, which is negative 4. Okay, so that's the acceleration. The speed of the particle Q, increasing, decreasing, or neither at time t equals 2. Well, I know from part B, v of Q at 2 is positive. I did that analysis here. So since the velocity is positive and the acceleration of the particle is negative, that means my velocity values are decreasing from positives to less positives. Signs are opposite. You got velocity going in one direction, acceleration going in the other direction. Your speed is decreasing. Part D. Find the position of the particle Q the first time it changes direction. Okay, so here's the first time it changes direction. T equals 3, V of Q changes sign. That means I'm going from right to left or left to right, so that means we change direction. Now, two ways to do this. To find x of 3. You could either, since you can, anti-derive and find c. So x of t would be, let's see, v is t squared minus 8t plus 15. So 1/3 t cubed minus 4t squared plus 15t plus c. I know x of q of 0 is 5. So that means c is 5. So x of t is equal to 1/3 t cubed minus 4t squared plus 15t plus 5. And then find x of 3. It's 9 minus 27 plus 45 plus 5. I'm just going to leave it like that. You can leave it like this on your test. If it's a no calculator question, the rest would be simplification. This is a fine answer. You could do the work. 9 minus 27 is negative 18 plus 50, 40, 30, 32. Okay. Or my unknown position equals my known position plus the displacement. When you do the displacement, you do not have to find c. I mean, it's not that hard, but you don't have to do it. T squared minus 8t plus 15. So I get x of 0 was 5. No. Yeah, x of 0 is 5. So that's the whole plus c. It's found right there. Plus displacement. So that's 1/3 t cubed minus 4t squared plus 15t plus c. I don't need this c. It's right there from 0 to 3. I get 5 plus, it's the same calculations. 9 minus 32 plus 45. Did I make a mistake here? No. Why did I say that's 27? Oh, because I'm plugging in 3? No. 9 times 4 is 36. Yeah, so 50 minus 27, 20, 23, not 32. Okay, and just confirming 5 plus okay. All right, now I have a calculator. Don't do parts C and D. Do everything. Given velocity of a particle, position at time 4 is 2. X of 4 equals 2. This is important, making sure you write this down. At time t equals 4, is the particle speeding up or slowing down? Okay, well, we got to look at the signs of velocity. So A of 4. I'm going to just plug in 4. And for A, for V, V of 4, I got 1 plus 2, 1 plus 2 sine. 16 divided by 2 is 8. I'm just going to do that real quick. 2.978. That's positive. All I care about is that it's positive. Then v prime of 4, which equals a of 4, I will use math 8. Math 8, let's take the derivative of 1 plus 2 sine t squared over 2. Close the parentheses. That's good with respect to x at x equals 4. If you have the newer operating system, it's easier. We see that's negative. So velocity is positive, acceleration is negative, the speed is decreasing. You are slowing down. V and A have opposite signs. Part B, find all the times when the particle changes direction. Justify your answer. Okay, so your justification needs to say like, particle change directions when your velocity changes sign. So this is my justification. So since I have my calculator, I can graph my velocity function. 1 plus 2 sine t squared over 2. I'm looking for the interval from 0 to 3. Just my window, so I have my interval from 0 to 3. I see how many times does it change. Only once. I can graph y equals 0 as well to find that intersection. That's when I change signs from positives to negatives. That's at t equals 2.707. You don't need anything else. This is proper justification. You need to include justification if they're asking you for it. If you don't, you're not going to earn all the points. So if it asks for a reason or to justify, you have to explain. Particle change direction when v change sign, and then just give your answer. You don't have to talk about how you found your answer. Find the position of a particle at time t equals 0. Classic, an unknown position equals a known position, because I can't take the antiderivative. So an unknown position equals my known position plus the displacement. Now be careful, this is an end. This is my start. I'm going to have to look at a displacement from a starting time of 4 back in time to an ending time of 0 of v. You don't have to include the entire equation. Instead, x of 4 is 2. So let's do the calculations. 2 plus integral of v, 1 plus 2 sine x squared over 2. Close. With respect to x, from 4 to 0. Make sure those are in the correct order. You get a position of negative 3.185. Numerical dyslexia there. Part D, find the total distance. Piece of cake. Distance, integral from 0 to 1, 3 of the absolute value of v. If v is listed, you do not have to rewrite this. I would expect you write what you're using, what you're typing into your calculator. That will help you get some partial credit in case you don't get the right answer. And it's also expected of you to write down what you're typing into your calculator. So I already did the integral here. I'm going to get rid of the 2 and add an absolute value. Close my parentheses to close any arguments, and I will get the answer when my calculator is done. Negative 6.710. Wait, what? What is wrong with this? I know what's wrong with this. Why did I get a negative value? I should be getting a positive value. Well, I have 4 to 0 still. 0 to 3 makes sense. Distance is always positive, 5.30. 2, 1, 5.301. Next problem. Another calculator problem. Don't just do part B, do all the parts. I was just copying this from your homework. Here's the velocity. It's known the initial position. If you're not comfortable with S, use X. Speed. What is the speed of the particle 2? Speed is the absolute value of velocity. So when velocity is positive 2 or negative 2. I'm going to go ahead and graph my velocity. Negative 2 plus t squared plus 3t to the 6/5 minus t cubed. I'm going to graph 2. I'm going to graph negative 2. We did this in our first homework. This is from 2 to 4. Adjust my window. 2 to 4. There and there. Second calc intersect. Here's when it's equal to 2. And then second calc intersect. My first curve is the blue one. My second curve is the black one. Use up to access the black curve. And you'll get the other intersection, 3.473. Part B. Write an expression involving integral that uses position S of t. Use an expression to find the position. Okay, so you can't anti-derive. So you'd have to say my unknown position equals my known position at 0 plus my displacement. Now notice I'm going to use a t up here to represent the time. And then we want to find position time 5. S of 5 equals S of 0 plus an integral from 0 to 5 of v. So S of 0 is 10. I got 10. Quit. 10 plus math 9, an integral of negative 2 plus t squared plus 3t to the 6/5 minus t cubed. That's my function with respect to x from 0 to 5. Negative 9.207. Let's see if I typed everything correct. Negative 2 plus x squared plus 3x to the 6/5 minus x cubed with respect to x from 0 to 5. And I added 10, and I get negative 9.207. Find all the times at which the particle changes direction. It's easy. Particle changes direction when the velocity changes sign. Velocity is positive, I'm going to the right. Velocity is negative, I'm going to the left. Particle changes directions when velocity changes sign. That's your justification. You have to write this down. Okay, so 0 to 5. Graph my velocity. I already have it graphed, which is nice. Window 0 to 5. How many times do we cross through the x-axis and change directions? 1, 2. Second calc intersect. There's 1 at 3.317. Second calc intersect, pop over to the other one. Enter, enter, enter. 0.536. Okay. D is the speed of the particle increasing or decreasing at t equals 4. Okay, so we got to look at the signs of velocity and acceleration. V of 4. Quit. See if I can do some work here. Whatever. v of 4. So I got negative 2 plus 4 squared, 16, plus 3 times 4, which is 12, to the 6/5 minus 4 cubed, 64. It's negative. So I'm going to write that down. Do I care what the value is? Actually, no, I don't for speed. Now, v prime of 4, which will equal a of 4, I'm going to use math 8. Let's take the derivative of negative 2 plus, whatever. I was thinking about maybe using a previous one, but I'll just do the work. T squared plus 3t to the 6/5, close parentheses, minus t cubed with respect to x at t equals 3, 4. It's also negative. Yeah. So, since my velocity is negative and my acceleration is negative, my speed is increasing. They ask you for a reason, that's like justification. You literally just have to say the signs of v and a are the same. Or you'd say v and a have the same direction. This is perfect justification. 2012, no calculator, trig function. Okay, particle is a position negative 2 at t equals 0. Let's remind ourselves of that. X of 0 is equal to negative 2. When's the particle moving left? Particle moving left when our velocity is negative. Got to take my velocity, set it equal to 0. We talked about this before. We can replace this with a y, or you can think about how you need a pi over 2, so you get 3, and then 3 pi over 2. I would need 9. So 3 and 9 are my answers. Here's another way of getting those answers, 3 and 9. Cosine is equal to 0 at pi over 2 and 3 pi over 2. And others, but let's just start with those and see if they fit. Multiply by 6, divide by pi, and you get t values of 3 and 9. Those are between 0 and 12, so that's great. I will then, on my sine analysis, start at 0, go to 12. I got 3 and 9. I can plug in any value into the cosine. So let's start with like 1 cosine of pi over 6, positive. 4, the cosine of 2 pi over 3, negative. You could also plug in 6, cosine of pi is negative. 11, cosine of 11 pi over 6, back to being positive. When are you moving to the left from 3 to 9? Part B. Right, but do not evaluate an integral expression that gives the total distance. Oh, isn't that a great 0.6 absolute value of v? That's it. That's all you need. Part C. You don't even have to write in what v is. You just have to make sure you have the absolute value. Find the acceleration. Is the speed increasing or decreasing at 4? Okay, so v prime will equal a. You got to use the chain rule for the derivative of v. So I got the derivative of the outside and the derivative of the inside. The derivative of the outside is negative sine pi over 6t times the derivative of the inside, pi over 6. This is the whole O and I. If you didn't get this or don't know how to get this, make sure you try and use the O's and the I's. A of what? 4 is negative sine 4. Pi over 6 is 2 pi over 3 times pi over 6. Sine of 2 pi over 3 is positive. I got a negative. I just know that's negative. Okay? I know that v of 4 from the previous problem is negative. Velocity is negative, acceleration is negative, speed is increasing because v and a have the same sign. Okay, that's your justification. That's all you need. Do not write paragraphs you don't need to. Part D, find your position at time 4. Either take the antiderivative of velocity to get x of t and find c. The antiderivative of cosine pi over 6t would be sine pi over 6t times the reciprocal of the coefficient times 6 over pi. That's tricky, but we've done a lot of these before, so we should be comfortable with it. Plus a c, and you want to find that x of 0 is -2. So I get 6 over pi times sine of 0 plus c is -2. So c is just -2. So you get x of t is equal to 6 over pi sine pi over 6t minus 2. And I'm trying to find my position at time 4. X of 4 equals 6 over pi sine 2 pi over 3 minus 2. Sine 2 pi over 3 is root 3 over 2. 6 over pi times root 3 over 2 minus 2. You can leave it like that, simplify it. The other way to do it is to say my position at time 4 equals my position that I know at time 0 plus the integral from 0 to 4 of velocity, which is my displacement. What you end up doing is you don't have to find c here, but you have c right here. X of 0 is -2. That's my starting. And then plus, you'd end up doing the same calculations, but just know that there's 2 ways to do it. 6 over pi sine pi over 6t plus c. I don't need it because it's right there. From 0 to 4 to find the change is same thing. Okay. 2011 calculator. 1, 4, 1, 2, 3, 4 to do. Okay, let's go. I got a velocity, I got acceleration for the same particle. X is not given. You can't take the antiderivative of that. So we're going to have to use this probably to find a position. I know that right away. Speed increasing or decreasing, part A. Give a reason. All you need to do is find V and A's sign. You don't have to write down the value. It didn't ask you to find the value. So you just need to sine e to the 5.5 divided by 4. Close that, plus 1. So V of 5.5 is negative. Let's find A of 5.5. It's nice that they gave you the acceleration. You could also, I could literally just do the second, insert a derivative of that with respect to x at 5.5, and I'll get the same value as I'm like, what's this plus 1? Where does plus 1 come from? Right there. 2 sine e. Oh, okay. It's not the derivative of a constant. Of course, the derivative of a constant is 0. Derivative of x over 4. Okay, I get negative. That will be the same exact value as if I just plugged in 5.5 into 1/2 e to the 5.5 divided by 4 cosine of e to the 5.5 divided by 4, close parentheses, same value. See? Look at that. Why is this different than this? Because this one approximates, your calculator approximates. All I know is that the acceleration is negative. That's all I care about. Since velocity and acceleration are in the same direction, the speed is increasing. V and A have the same signs. Part B, and that's your justification. That's all you need. V and A have the same signs. Average velocity, nice. 1 over B minus A, integral from A to B of what we're trying to find the average of. Velocity, boom, right there. Can't use change in position. I have to use my calculator. Don't know the antiderivative of this, so I go 1/6, math 9, integral of 2 sine e to the t over 4, close, plus 1. Well, close the sign, plus 1. With respect to x from, what are we doing, 0 to 6? 0 to 6. Close. 1.949. Beautiful. Part C. Total distance. Gosh, this is such an easy free response question. Calculator, 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 calculator. Calculations. Speed times time. Area under speed graph. Let's pop this sucker back. 0 to 6. Get rid of this 1/6. Gone, gone, gone. Math. Oh, sorry. Go ahead. Insert an abs. Close the abs. Whew. 12.573. D. Particle changes direction exactly once. Find the position of the particle at the time. You had a quiz question like this, okay? Particle changes direction from 0 to 6. When does it change its direction? Changes direction when V changes sign. When we change from positive to negative, change from right to left. Negative to positive, we change from left to right. Use your calculator. Let's graph V. Two sine e to the t over 4. Close that. Close that. Plus 1. Changes direction once between 1. 0 and 6. Window. 0, 6. Graph. Right there. Second. Calc. Intersect. Give me that number. 5.1955223. Notice, I'm going to put that entire value into my calculator, okay? Because this is not my final answer. My final answer is to find the position of the particle at that time. The position at this time will equal, since I can't take the antiderivative of velocity, it will equal the position I know plus the displacement between the two positions, which is the area under velocity. It's the velocity times time. So I will have 2, get out of here, 2 plus, I'm going to go back here. That integral of 2 sine e to the x over 4 plus 1 with respect to x from 0 to, this is where our number comes into play, 5.1955223. Close that. Enter. 14.134. Sweet. Three more? I can finish it in 10 minutes. Not. Okay, here's a velocity curve. Areas of the regions are 8. I'm going to say that's got to be -8, 3, and 2. So I'm going to say that's -2, or the integral will be negative. Find both the position of the particle and the particles furthest to the left. Justify your answer. Okay. A. Furthest left. When x is a min, that's one. X prime, which equals v, equals 0. That's going to be at 3 and 5 are candidates. But if I do an analysis of my signs, I'm going from 0 to 6. and I'm looking at x prime, which is v. I got 3 and 5, negatives, then positives, and negatives. Negatives, positives, negatives. So furthest left, my candidates are 3 and 6. Now, for justification, this is a little bit tougher. Like, you got to say the furthest left is when x is as a min, and then your justification would be at a relative extrema, relative min, or an endpoint. Now, you could also explain why 0 is not a candidate, why just 3 and 6 are. But it's probably easier if you just say, like, okay, relative min at x equals 3. Because x prime changes sign from negative to positive. Now, to find x of 3, I first noticed that my particle is at position -2 at t equals 0. This is going to be very much used. So, x of negative x of 3 will equal x of 0 plus my displacement, which is the area under my velocity curve. X of 0 is -2. -2 plus the integral from 0 to 3. So -2 minus 8 is -10. I already know x of 0 is -2. That's out. Let's find x of 6. Well, it would be x of 0 plus the integral from 0 to 6 of v. That's going to be -2 minus 8, which is -10, plus 3, which is -7, minus 2, which is -9. We did most of those problems, I think, for our last homework quiz. Last homework. So x equals 3, which equals -10, is when we are furthest left. We use the candidates test. Explanations for absolute maxes and mins are a little bit tricky. How many times is the particle at -8? I mean, you know you travel, since velocity is negative from 0 to 3, positive from 3 to 5, and then negative from 5 to 6. You know, v of 0 is -2. Sorry, not v of 0. X of 0 is -2. X of 3 is -10. X of 5 is -10 plus 3. That's -7. And x of 6 is -9. X of t must equal -8 1, 2, 3 times. Each within the interval 0 to 3, 3 to 5, and 5 to 6. Part C, speed of the particle increasing or decreasing from 2 to 3 gives a reason for your answer. From 2 to 3, velocity is negative. A, positive. How do I know A is positive? Tangent slopes of V, which are A, are positive. Since that's positive and velocity is negative, the speed is decreasing. The signs of velocity and acceleration are opposites. Part D, during which time intervals is the acceleration negative? V prime, which equals A, is negative from 0 to 1 and from 4 to 6. All right, this will be part 1 of the video. Part 2 will be the last 2 problems. Do I want to close this, or do I want to pause? How about we just say this? This is from homework 7.4 video. The entirety is from the homework 7.4 video. Please just watch this. This is a tricky one, very tricky. And then this was from also the 7.4 video. So I believe the entire questions were there. Let me just check homework 7.4. This was the 2004 one. Yeah. So both of these questions, the entirety is in the homework 4 video. If you'd like to watch these, please go to the homework 7.4 video /answers. The other ones, I can understand how it'd be tough to kind of piece them together from all 3 videos, but these I feel more comfortable saying, since I already did the entirety of them on the 7.4 video and the answers, that you can find them. All right, that's your review. There's going to be some parts on your free response questions that are going to be very tough. Just know that the tough questions that don't involve stuff that we've talked about, that involve like past material, they're going to be worth less points, like 1 point for a really tricky part from something else. I'm going to weight things so that the stuff we've talked about this unit will be assessed primarily. Thank you.